All right, I guess we will get started. Again, thank you for everyone for joining us today for our Innovating Industrial Solutions webinar. I'm Kelsey Buchanan, and I'm going to be your moderator for today's presentation. Before we dive into some introductions from Elizabeth and Jack, I want to go over just a couple logistics. If you have any questions throughout the webinar, you can submit them at any point during the presentation via the chat or Q&A feature at the bottom of the screen. We will address these questions at the end of the presentation. And then if we don't get to everyone's questions during the presentation today, we will certainly follow back up with you. Additionally, we will follow the webinar up with a survey. This is your opportunity to provide us with feedback on how we did today. Ask any additional questions you may have about today's webinar, or suggest new topics for webinars you'd like to hear in the future. We always say this is a two-way street, so we want to hear from you and make sure that we're answering the questions that you have. We are continuously striving to really improve and evolve these webinars, so if you do have any comments or suggestions as how we can do better, we definitely want to hear from you. We do use this feedback to improve our webinars and provide the information that has the most value to you. So with all of that said, I'll pass it off to Elizabeth. Elizabeth, could you start us off with an introduction?
Yeah, sure. Good morning. My name is Elizabeth Sheehan. I'm a product manager based out of our Denver, Colorado headquarters here at Johns Manville. I was previously a product manager for metal, but currently preside over our foam portfolio, and I share the high temp industrial portfolio with Jack.
And I'm Jack Bittner. I've been in the insulation business for more than 40 years, and about half of those have been with Johns Manville. I'm currently the industrial product manager for high temperature insulations. And Liz, I don't know if you mentioned you have 10 years at JM, and this month is your 10-month anniversary. So
it is, yeah.
Congratulations. I saw
Thank
that
you.
this morning. So I will start the presentation right from here. At Johns Manville, we've got a multitude of insulation materials and accessories that are focused on the industrial insulation market. We're going to talk about a lot of these products as we get into the presentation today, but you can see there's a multitude of materials we offer. And our goal is to be as big of a full line supplier to you as we possibly can. So if you look at this slide, on the left-hand column, the products are listed, and they're generic products that are applicable to the industrial insulation market. And Johns Manville has 7 out of, I think it's 10 of them listed there that we offer to the market. So we aim to be as big of a full line supplier as we can. And some people will ask, well, how come you just don't have calcium silicate? And the answer is, look, because there is no silver bullet here. Every product has a place where it performs better in certain conditions than some of the other ones, and that's why we want to have as many as possible. So there's a lot of reasons to insulate in the industrial insulation market. They're listed here. There's still more, but the primary one on this is process control. The customers, the facilities trying to make a product, and that product needs to be made at certain temperatures or it doesn't work. And if they don't have control over that process, then the product that they're putting out the door is going to be inferior. So they've got to maintain tight control of their boilers and the operating temperatures to generate the products they want. That's the primary reason to insulate. A secondary one is personnel protection, and the other ones follow along behind it, with sustainability being a pretty close third, which is pollution reduction and energy conservation. This is a chart that I got out of the MICA manual. And, a lot of times in the business, we talk about, well, these are high temperature products. This is chilled water. This is cryo. So, the question is, what temperatures are we talking about here? And this is a nice summary that I got out of the MICA manual. And what we're going to be talking about today is pretty much everything on here except for the refractory materials. Johns Manville's not in the refractory business. And this is a similar chart to that last one, except these list those products that I had on the one of the initial slides. And everything here in blue, polystyrene, polyisocyanurate, mineral wool, and calcium silicate, are products that JM offers. And you see here the temperature ranges for all the materials. There's a lot of overlap, and one of the reasons that there's overlap is some products are better suited for certain applications than others, and that's why they will all overlap. You just have to pick the best ones based on your conditions. So these are generally the high temperature products we have at Johns Manville. We have a calcium silicate, which is thermal 1200, our mineral wool pipe and board products, some high temperature boards, which are super fire temp, and then we've got a couple of accessories that go along with the high temperature products. We're going to talk a lot today, oops, hit the wrong button, about water resistance and hydrophobicity. So I do want to put just a brief slide here on what we're talking about and why. Corrosion under insulation is a huge issue in the industrial insulation market. And there's a lot of estimates of what it costs facilities per year. And there was one study here that it costs $84 million annually per facility. And that's on average. So there's a lot of them that are bigger, that have a bigger cost. And some are smaller that have a smaller cost, but on average, CUIs consumes about 40 to 60% of the maintenance costs. And as a result of that, folks' main efforts when they design systems are keeping water out of the system. And over time, that's very hard to do. There will be some water incursion. So the next step is make the insulation either hydrophobic or water resistant. And what does that mean? Well, hydrophobic is kind of like water going off a duck's back. And certain insulations are hydrophobic. Cellular glass, expanded perlite, and silica aerogel products are in that classification. Other materials are water resistant, which isn't hydrophobic, but it's also not, I just lost that word, hygroscopic. They do resist and repel water up to a degree. And our calcium silicate and mineral wool that we offer are water resistant. But pretty much all the industrial insulation materials these days are either water resistant or hydrophobic. So let's talk about the insulations, and we'll start with calcium silicate. Johns Manville's brand is Thermo 1200. Typical applications, refining, petrochemical, and power are our biggest, and we also do some in pulp and paper and a few other associated industries, but refining, petrochem, and power are our major markets. The benefits of thermal 1200 and calcium silicate in general, it's got a pretty decent K factor, and again, we're going to talk about K factors a little bit, but that's the insulation value. And there are those of you who know more about fiberglasses, for example, in mineral wools, their thermal conductivity or K factor is less than 34. It might be 22, 23.23, and they're better insulators. But again, we're talking at low temperatures. So calcium silicate is a much better insulator than some of those other materials I just mentioned at high temperatures, which is the application for it anyway. Our Thermo 1200 has a corrosion inhibitor contained in the material. I'll talk about that a little bit shortly. It is water resistant. Its greatest strength, I've always said, is its compressive strength. And that's pretty much what allows it to be in applications that are, I know of some that are more than 25 years old. And the maximum service temperature of all our high temperature insulations is 1200 degrees. So let's talk about water resistance. In 2017, Johns Manville made our calcium silicate thermal 1200 water resistant. And what does that mean? Well, compared to before we made it water resistant, look at this chart. The yellow or gold bar is our old one. That's thermo 12. And it was not water resistant. So you can see in a 20-minute rainstorm, it would absorb as a percentage of product weight, 88% of that moisture. Versus now that we've made it water resistant, that would be in a 20-minute rainstorm, 7%. So the old stuff absorbed water very easily. And water resistance became important for CUI reasons, and also contractors like the fact that it's water resistant because it gives them more time to install the jacketing. One of the versions we make, and we've always made in calcium silicate, is we make, pipe insulation, which is preformed to fit around the pipe, and then as the diameters, excuse me, get bigger, we've made scored block, which you can see in this picture. It's designed for large diameters to where you put the material, the block on it, and you push it against the surface and it cracks and breaks to form the cylindrical application, so it fits tighter on the vessel. However, you see in this picture, sometimes when that vessel gets really big, those V's don't close. So now what do? Well, we've got 3 alternatives for a tighter fit on large diameter vessels. What we call beveled lags, curved segments, and curved radius block. I'm going to talk about curved segs and curved radius block first. Those are cut to fit the actual diameter or circumference of whether it's a vessel or a large diameter pipe. And the sides are angled to fit tightly against each other. So it does away with those V's that might not close. We have 2 versions, one's 6 inches wide, one's 12. They're the same product, just one's wider than the other, which results in less labor. And then going to bevel lags, at some point, that vessel surface might get so large of a diameter that you don't need to cut a curve in the block. So we offer beveled lags where there's a angle cut on the sides, but the flat part on the inside fits very tightly against the vessel because the diameter is so big, and you end up with a nice tight fit with either one of these options that fit both snugly to the vessel surface as well as the no joints. They close up very well. Couple things to think about with calcium silicate. It's really up. There are various options. You can select a lot of different materials, but it's really up to the owner or the specifier to qualify the materials, and that means meeting the ASTM requirements and other testing requirements that the owner might have prior to selecting the material. We also have a corrosion inhibitor in the insulation calcium silicate we make today. That corrosion inhibitor was put in 2002. And I'll talk a little bit about that here next, but just be aware that there is a corrosion inhibitor that actually works in our product. And CalSil requires a higher level of craftsmanship to install. It's a cementitious product, so cuts have to be pretty accurate. It's easier with mineral wool because it's a fibrous product, so if the cut's not accurate, you can pretty much push it up against the nozzle or the valve stem and band it on, and you're good to go. With calcium silicate, you can't do that because it's cementitious. So a little more skill level on the part of the contractor. Getting back to that corrosion inhibitor, our corrosion inhibitor is called XOX. And a lot you see it quite often today that pipes are painted or coated before insulation's applied. And one of the reasons folks do that is to keep moisture off the surface of the pipe. When moisture contacts the surface is when you can have corrosion happen. And the XOX actually provides a protective coating to the pipe similar to, and it performs the same way as painting the pipe or putting some other coating on it. But this is contained in the material itself. 95% of our chemistry includes a blend of at least 4 different corrosion inhibiting ions. It keeps the pH level around 10, and that's well up above the acidic level where corrosion can occur at less than 7. And those corrosion inhibiting properties are there for the life of the system. They don't leach out over time. And they're actually activated when water is present. So it's a water activated solution. If there's no water there, you don't need corrosion inhibitors. But once water enters the system, the chemistry provides with the water as it gets to the pipe, it coats it. So it keeps the water off the pipe. And mainly another term for the protective coating is a buffering effect. And it maintains the pH at a high enough level to help to inhibit the corrosion. We also have some heavier duty calcium silicate boards. Our brand name is Super CalTemp Gold 1700 and also Super Fire Temp. 1700 degree block is formed in the form is produced in the forms you see here now, flat block, and also scored just like our regular thermal 1200 calcium silicate, except it's good for applications up to 1700 degrees Fahrenheit. We'll talk about where this is used on the next slide, but we also have, I want to mention Super Fire Temp, which are higher density boards that are used for pipe saddles, pipe supports, various applications I'll show you on the next slide, but these have service temperatures up to 1800 degrees Fahrenheit. Primary applications for both of them, both materials, the Super CalTemp and the Fire Temp, they provide a 2-hour rating for UL 1709 as passive fire protection. And for those of you who aren't familiar with 1709, that is a hydrocarbon pool fire where the temperature, because it's hydrocarbon in this test, goes from 0 to 2000 degrees in 5 minutes. And the insulation has to perform for 2 hours or 120 minutes. These are primary applications for both of these boards, the Super CalTemp Gold and the Super Fire Temp products. One of the applications we're seeing more and more of these days with Super Fire Temp are fire training facilities due to its fire protective properties. And we published a technical bulletin here, I think last month, about that application. And this is a burn building you see here, where you can see the walls and the ceiling are lined with our Super Fire Temp board. And these are used to train firefighters. You know, they'll throw a couch, a bed, whatever it is in there to stimulate a room, and then set them on fire, and then send the fire department in to put the fire out. And it's designed to be reused. These panels you see on the walls, there are some instances where there are 7 to 10 years where those panels haven't been replaced through multiple training classes. Now I want to move to mineral wool, which is fibrous product. Some of the benefits, you notice the K factor. The K value is 75 degrees. Calcil was 0.34. This is 0.22. K values are similar. I look at them like golf scores. The lower, the better. So just based on this fact, at certain temperatures, mineral wool is going to be a much better insulator than calcium silicate. The other advantage, big advantage, is acoustics. And we see a lot of specifications calling for mineral wools for insulation and acoustics. It's also easier to install, like I mentioned when I talked about CalSil, because it is a fibers product. And it's one of the lower cost ones, labor and materials, that you can find on the market today. In addition to pipe insulation, we make boards. Our industrial boards will make from densities of 4 pounds up to 10 pounds per cubic foot. And those boards are rigid. They're primarily used on flat ducts and large diameter vessels. But we also make the same type boards, same densities, in a flexible form, which we call bats, but they're really flexible bats. And they just wrap easier than a boardy board around cylindrical ducts, turbines, and larger diameter vessels. All of our mineral wool insulations, whether it's pipe or board materials, are water repellent. Additionally, we make a pipe and tank wrap, and there is one offering made out of continuous fibers. In other words, if you look at the one on the left, the fibers would be parallel to the surface of the pipe. There's also what they call a lamella style pipe and tank wrap, which is another pipe and tank wrap, probably the same densities as the one with the fibers parallel, but the fibers in lamella, it's cut out of board and glued to a facer. So those fibers are perpendicular to the surface. The interesting thing, and I just want to point this out, is both of these products might be made out of 6-pound density material, but simply due to the fiber orientation, the thermal conductivities, the K factor, the insulation value, however you want to look at it, is different. And it's primarily due to the orientation of the fibers. Fibers that are parallel to the surface insulate better. It provides a more difficult path for the heat to move through the material versus a perpendicularly set fibers. So with mineral wool, you hear a lot about binder burnout. What's that all about? Well, binder is an additive that holds the fibers together. It gives them their loft. In mineral wool and other fibrous materials, that binder is an organic material. So it'll begin to oxidize or burn out at about 450 degrees Fahrenheit. And you can see on that picture at the top, the gray part is where the binder is oxidized. The brown part is where it's beginning to oxidize. And of course, on the surface where it's cooler, the binder's still fully there and intact and doing what it's supposed to do. The good news is the binder doesn't impact its insulation value at all. But without the binder, the compressive strength is compromised. Again, as I mentioned, the binder is what holds the fibers together. So if the binder's not there, the fibers are still there unless you got a bunch of vibration, which will cause the fibers to now move and settle at the bottom. Gravity always wins. And mineral wool is a softer product. It's spongy. And without the binder, it's even more spongy. So it's more likely to be damaged if it's not treated carefully. When you damage it, the compressive strength suffers. So now that 2 inches might now be 1.5 inches, and your thermal conductivities are different. Your insulation value is different, and not in a good way. So some things to consider when you're looking at choosing mineral wool. It does have a lower compressive strength. So if there's physical abuse, people are going to be walking on the insulation, which you're not supposed to do, but we all know it happens. A higher compressive strength like calcium silicate would be the better choice. The K factor is pretty low, but above temperatures of 500 degrees Fahrenheit, the calcium silicate also at that point actually becomes a better insulator. The K value curves cross. Mineral wool is a shorter service life in general, just due to the low compressive strength. Any damage to the jackets, which will now allow water to get into the system. And now you have the higher potential of corrosion. And just fibrous products in general have a low vibration resistance over time. Gravity also always wins. And finally, we offer two different high temperature accessories. One of them is the CalCoat 127. It comes in 40-pound bags. You mix it with water and trowel it on or onto the pipe insulation where there is a chip, a damage, the seams don't meet exactly right. You fill in voids with this product. In addition, we have Calbon Gold, which is a sodium silicate-based adhesive, which is used to glue broken pieces together, but also for gluing the miters that are cut for elbows to each other and other large sections or special shapes. And it dries very hard. So if you drip it on the floor when you're doing this and you don't clean it up, you're going to have to chip it up later. And with this point, I'm going to turn it over to Liz.
All right, so now we're gonna move into our metal jacketing and accessories product line. I am gonna go a little quickly, so just bear with me. There's just a lot of information to cover within this hour, so hang tight here. All right, so the function of metal jacketing is to protect that insulation system from damage from physical abuse. Physical abuse can arise from a myriad of sources, including personnel walking on pipe insulation systems, other trades in your facility, such as vehicles like fork trucks in a loading dock area hitting insulated pipe, pipe supports, things being hung from insulated pipe, weather such as hail, wind, the presence of corrosive chemicals, and even animals. I think we have a picture somewhere of a mama bear and her cubs choosing to walk on an oil pipe instead of on the ground for easier walking. So it's not a matter of if your pipe is going to get damaged, it's more of a matter of when, unfortunately. The secondary function of metal jacketing is to reduce water infiltration into your system. So to help facilitate this, the longitudinal joints on horizontal pipe need to be located at about the 3 or 9 position on the pipe. And all joints on pipe and tank insulation should be oriented to either naturally shed water or face away from prevailing winds. And then another step to keep out liquid water is to seal the metal jacketing joints with flashing sealant applied inside and not on the outer lip of the joints. This is a little controversial. Some people think it helps keep water out of the system, while some people think that it prevents or slows the evaporation of water that is already inside the system. There's not really one that's proven right scientifically. Our opinion at JM is that sealing of metal jacketing joints is probably beneficial. We recommend doing this, but it is a mild recommendation and not something that absolutely must be done. And the ultimate decision on this is up to the specifier of the insulation system. So outside of North America, there's a lot of coated steel used in that market, such as Galvalume, galvanized and aluminized steel. But these are really rare in North America. And in our geography, aluminum is used most of the time for metal jacketing. It is cheaper, it is easier to handle and install, fabricate, and it's safer since the edges aren't as sharp as with stainless steel. Stainless steel is really only used in 2 situations. Number one, where the environment is particularly corrosive, such as a facility located next to the ocean or downwind of, a coal-fired power plant, where the facility produces lots of corrosive emissions. And then second, scenarios where the insulation is intended to provide some sort of fire protection for the underlying pipe or tank. In this case, you want to use stainless steel jacketing. It has a higher melting point. That's going to be better than aluminum, which has a lower melting point of about 950. And we strongly recommended that all metal jacketing have a 3-layer, 3 milliliter thick factory heat laminated polyfilm moisture barrier on the interior surface. That helps to prevent corrosion on the hidden interior surface of the metal jacketing. And I will get into that in a few slides. And then just to note, the aluminum ASTM is C1729 and stainless steel is ASTM 1767. Those are differentiated based on rigid versus non-rigid insulations. So here is our metal jacketing accessories. They're all shown above. We do have crossflow jacketing, which I will get into. We have a series of other jacketing facers, such as stainless steel, aluminum, and painted aluminum, and elbow fittings. We note that our aluminum elbows have that polyfill moisture barrier applied on the interior surface, where our stainless steel elbows do not. It's not a matter of if we can, it's not a necessary need in the market. And then we have rolls that are both available in sheets and cut and roll. We have corrugated metal accessories to go along with those, some acoustical products, as well as others available online. So let's get into the topic of moisture barriers that I just mentioned. We have a polyfill moisture barrier factory heat laminated to the inside surface of our metal. It's to reduce the likelihood of corrosion, so it would actually be more accurately called a corrosion barrier, but we've all settled on the name moisture barrier, so that's what we're going to call it. So vapor retarders used on the outside of the insulation are sometimes improperly called moisture barriers, but we, again, don't recommend using that. So this inhibits corrosion when water or water vapor can enter the insulation and exist between the insulation and the jacketing. And hot applications are between the vapor retarder and the jacketing, and cold applications. The water can cause pitting or crevice corrosion on that interior surface of both aluminum and stainless steel jacketing in hot and cold applications. There's also another type of corrosion called galvanic, which you also want to prevent. And again, for all these reasons, we strongly recommend the use of polyfill moisture barrier, or shortened to PFMB, on our metal jacketing where it is available. It is not a proprietary product. A lot of manufacturers use this. It just comes in different colors, etc. There we go. All right. So here's the performance of 3 different types of moisture barriers on some of the key properties and testings that have been performed in the past. The 3 types of moisture barrier are paint, polycraft, and polyfilm. So painted moisture barrier is a single thin layer. Polycraft is a single layer of polyethylene film with craft paper backing, again, 1 layer. And then polyfilm is a 3-layer film with a total thickness of 3 mils. So what I want you to, the big takeaway from this obviously is the polyfilm results. And I want you to look at the pinhole testing. For the most part, there are testing for the total test for pinhole concentration, water vapor transmission, and toughness and flammability, but pinhole is kind of the clincher here. So there is an ASTM test method for these. And essentially what you can tell is when pinholes were introduced, polyfilm performs the best in reducing the occurrence of those pinholes. And the reason pinholes matter is because every time you have a pinhole, you have an opportunity for water to enter your system. So as much as you can reduce the presence of pinholes, you want to. And the number of film layers is also a key difference. 0 or very low pinholes in PFMB arises from it being 3 bonded layers, whereas pinholes in any 1 layer will not line up with holes in another layer. So that's that problem with paint and polycraft. So for all these reasons shown here, polyfilm is very strongly recommended over either the alternative moisture barriers shown on this slide. All right, so now we're going to move into our pressed metal elbows. So metal elbows are the jacketing portion that goes over the insulated elbows in piping systems. We produce these jacketing elbows in 2 metals, like I said, aluminum and stainless steel. Our aluminum comes in 1100 alloy with that PFMB on the interior. And then our stainless steel come in T316 alloy, which is going to offer a higher corrosive resistance. And they have the bare interior and exterior. And both of these comply with their associated ASTM requirements. This is our slide simply showing the availability of the elbows we offer. We offer in 45 and 90 degrees, short and long radius, and what we call ball type fit. So our pressed metal elbows are designed to fit over 2-piece preformed elbow installation that's sized to comply with ASTM C450 and C585. The target overlap at the longitudinal joint of the elbows is 5/8 inches at each of the 2 joints, and it can go as low as 5/16, but we don't necessarily recommend allowing the overlap to go any lower than this. The target for the butt joint overlap with adjacent straight pipe jacketing is 2 inches. And then the pressed metal elbows are secured with screws, rivets, or bands, but only on cold pipe. Bands are the only item that should be used. I'll explain that again later. But when you have screws and rivets on cold insulation, you're going to rupture that vapor barrier underneath and you're going to render it obsolete immediately. We do have a number of documents on the installation of our pressed metal elbows available online. So let's talk about sizing. Our pressed metal elbow jacketing sizes are identified by a numerical designation from 1 to 56, and then Q1 to Q9 for our larger 4-piece elbows, which we call quads. So the numbers are specific to each elbow type and metal type. So like a 45 aluminum, a 90 stainless, so on and so forth. These numbers don't indicate size though. They are literally based off of the models that we pressed the pipes on, or the molds. So they're just a numerical name assignment to each elbow. The larger numbered elbows are usually, but not always, a larger size. So for example, an 18 aluminum 90 is larger than a 10 and a 44 is larger than a 39. But there are exceptions. The person selecting the elbows must always refer to the sizing tables. And I'll show you an example of this here. All right, sorry about that wait. So what I meant on the previous slide we're going to show through a visual aid using our 90-degree long radius sizing chart. So if the number elbow specified in our table does not fit, it is not correct to simply use a size that is one number larger. So in this case, we have a 21, and if that 21 doesn't fit, you're not just going to jump to a 22. Instead, looking at this table, the next larger size will be one cell to the right. So in this case, when our 21 doesn't fit, you're actually going to pick a 27. That throws some people off, but if there's any confusion or questions, our customer service team are experts in doing this, so just give us a call. We do this stuff all the time, so don't sweat it. So now we're going to move on to our painted aluminum jacketing products. All right, so we can provide our aluminum jacketing with paint on the exterior surface. Our stainless steel jacketing is not routinely painted. The painted aluminum provides 3 benefits. It changes the appearance for aesthetic appearances, and some end users find the product more aesthetically pleasing. It also increases the emittance from 0.1 to 0.5 and 0.8, depending if it's clear paint or pigmented. That is important, but essentially emittance reduces the required insulation thickness for condensation control and personal protection design criteria where jacket surface temperature is critical. We also offer, it improves corrosion resistance compared to bare metal. And it's still not as corrosion resistant as T304 stainless. Painted aluminum will approach this performance, so it is a step from bare aluminum. Here at JM, we offer 2 standard paint colors, white and gray. We do have additional colors based on request. So for example, we do have a lot of jobs with Bureau of Land Management where they will want like a forest green or a sand color, and that helps those pipes blend into the environment where people don't want the pipes as obvious in their environment outside. All right, so moving right along, we have profiled metal sheets. We offer 2. One is a box rib and deep corrugated. Box rib is obviously a steeper, more angled corrugation, and then we have our deep corrugated, which is that more traditional look. The important note on these is you're not going to put these horizontally because water will pool in those rivets and cause corrosion. So these are for vertical application on large tanks and vessels. So for time's sake, I'm not going to go through all of this in detail, but box rib we do offer in aluminum and stainless steel, typically in a stucco embossed pattern. And then on our deep corrugated, it is offered in smooth, stucco embossed, and painted. It does have that PFMB on one surface. And again, both of these are going to be for vertical cylinders, never horizontal. Next, let's look at our acoustical jacketing. We have 2 offerings. One is our mass-loaded vinyl used alone. This can be used as an additional layer or layers under the muffle jack, which is shown on the right. We offer it in both 1 pound and 2 pound per square foot. And then the other one is muffle jack, which is an 020 stucco embossed aluminum, which is laminated with that 1 pound mass loaded vinyl. That is protective jacketing and an acoustical benefit in one go. It's installed just like regular metal jacketing and has the same dimensions. Going into our accessories, we have a myriad of offerings here, both aluminum and stainless steel banding in 2 sizes. We do typically recommend stainless steel banding as aluminum is a little weaker and can snap and break. It is offered in rolls and pre-cut lengths. We offer a variety of fasteners. Again, on cold applications, only banding should be used to secure the jacketing and not those screws or rivets like I mentioned. We do offer tie wire to secure insulation in place, mostly in hot applications, and springs to help maintain that tension on banding around tanks in very large pipe as the tank and insulation system undergo expansion and contraction. So now we're going to get into our most recent innovation. It was launched a few years ago. It's called crossflow metal jacketing. I know I'm going fast. I really appreciate your guys' participation here. So the first metal jacketing is engineered to accelerate moisture egress from an insulation system independent of insulation property, thickness, pipe diameter, and process temperature. So that's important for reasons I'll get into right now. So Jack mentioned CUI, or corrosion under insulation. So when you heat up your pipe, you're going to have heat driven from your pipe through your insulation outside. And then during construction and temporary shutdowns, it might be necessary for insulated equipment to be idle. And when that happens, the pipe system is going to cool down. Moisture can enter the system if it's condensated on the outside, and it can go through the outside if it's not installed properly, travel through that insulation and sit on that pipe. And then when you heat up that pipe back upon kick up, it's going to kick that water back out, and it's going to make this cyclical pattern where you just have water going in and out of your insulation, and eventually it will render that insulation useless. So this is a really important topic that you want to address, because to repair it is egregiously expensive and hugely laborious. So as much as you can mitigate this, you want to. And it's just a really costly labor practice to do. So the way you can do this is through all of these methodologies. You want to have a properly designed and installed system. You can use pipe coatings. Like Jack mentioned, you have those hydrophobic and water-resistant insulations. You want to do maintenance, inspection, and repairs. You can add corrosion inhibitors like our XOX. And you want to provide a path for water egress to get out. But chasing one of these is not going to complete this goal. There's no silver bullet. You want to use all of these in conjunction to help your goal of mitigating CUI. And I'm not going to go into more detail on this because it's so complex. We could talk about it forever, but we do have lunch and learns. We have a ton of webinars on these papers, so please check it out online. So what is crossflow? Crossflow is our metal jacketing with diamond-shaped embossing pattern on the jacketing. That pattern actually faces inward to provide a pathway for water to travel if necessary. It comes in stainless steel and aluminum. And again, it comes standard with that moisture barrier on the inside. So let's look at some of the testing we did. To compare the drainage performance of different jacketing patterns, we essentially made mini models. So we used 4 types of insulation under 3 types of metal jacketing. So we have smooth, stucco, embossed, and crossflow. And then we forced water into the system through these PVC pipes that were sealed. And then we timed the rate at which the water left, and the time for the sample to stop dripping was recorded. So these are the first 2 results of stucco and smooth. And as you can see, depending on which one, we have mineral with smooth, so on and so forth. Here's the time for them to stop dripping. Now here's the results with crossflow included. So these results show the percentage improvement over the next best result. So this means that crossflow is 55% better than your stucco embossed over mineral wool. And then you have crossflow being 80% faster than aerogel being covered by smooth, 65% faster than smooth over calcium silicate, and 61% faster of smooth over perlite. So you can tell it really gets that water out of there as fast as it can. Here's another test we did, hot pipe testing in our facility at Littleton. We have a hot pipe. Well, actually what we did is we took insulation and we forced it to take on water. So we physically submerged it for hours till it was fully saturated, wrapped around the pipe, put crossflow over it, heated it up, had a weep hole, and we tested to see the time for water saturated insulation to dry. So how long did it take that water soaked insulation to dry? And the reason this matters is if your system is constantly fighting to stabilize its processing temperature, that's a lot of wasted time and energy that it could be using to do what you actually need it to do. So as you can see, crossflow still beats smooth and stucco embossed over mineral wool and calcium silicate. So that is going to save your system energy and resources. So let's look at some of the crossflow benefits for the contractor here. The install benefits of crossflow are that embossing pattern. It's easier to align bands faster. It hides damage really well. It reduces friction, so you can slide the metal jacketing over itself and it doesn't scratch as well either. Helps to slide bands in place, and then it installs and fabricates the same as our traditional jacketing, so you don't need extra tools to put this on your pipes. You just need tin snips and a box knife. Jack and I have done it a million times. I'm going to show you an install video that we did where we hired a third-party contractor. Kels, can you hit play on that? Thank you. This gentleman is named Johnny Laredo. He's from Apache. We brought him in to insulate this pipe. The top is being insulated or done with crossflow and the bottom is smooth. This is over calcium silicate. We did not give Johnny any measurements, nor did we let him save anything. We tried to control for as many variables as possible here. He had to measure both times. He did install weep holes during the installation. And as you can see here, he's kind of going to run away with this crossflow here. And it's going to beat the smooth here. I'll just let this run through here. Again, he was not allowed to save any measurements. He could not record anything. He had to start completely from scratch. So this result doesn't look crazy when you think about it, but this is not that long of a pipe. If you had this on miles and miles of pipe and you extrapolate this time, that's a big deal. That's a lot of labor and time that's going to save you if you're using crossflow versus smooth in this scenario. And on top of that, Johnny actually noticed a lot of things that we didn't notice when he first started. And those are some of those benefits that we talked about. He pointed these out. We didn't find these. Some of these, here's that diamond pattern. As a cut line to remove the need for a scratch line. You can just go straight through, which he actually ended up doing. Here's that sliding that I was talking about. You can slide it over because it has those pathways that create a little extra room. It also locks in on itself, which we didn't realize. So those are benefits that he found that we didn't initially as well. All right. Well, here we go. Sorry about that. All right. Here's our higher flexible strength testing for crossflow. The reason we did this test is a lot of people didn't believe that our 016 crossflow was actually 016 because it feels so much heavier than our smooth and stucco. So we kind of had to prove that it really wasn't 020 in disguise. And it is 28 to 30% higher in flexural strength than 016 smooth and 016 stucco. And the takeaway from this is that if you need higher flexural strength, but you either don't want to use 020 or it's not near spec, you can use 016 crossflow and get that higher flexural strength than smooth and stucco. But if you don't need to use 020, it'll also save you a little bit of reduced costs as well. So some of the aesthetics, we do have that embossed diamond pattern. It's entirely new to the industrial industry. Some customers just want to use crossflow because it looks really nice. So here's some real life examples. This is a hospital rooftop that used crossflow to insulate pipes as part of their hospital. It meets all of the requirements of a healthcare facility. This was in Washington State. This is a refinery where they used it on a large diameter vessel and the vessel head. This is a muffler. And here it is at SWICA Craft Competition in 2025. This is where that hands-on installation process includes metal jacketing, and this is a finished product from one of our competitors, or one of the competitors, I'm sorry. So we do recommend using weep holes in crossflow at the low points to allow that water to travel and escape the system. We encourage every 3 to 9 feet at low points, 3/4 inch to 1.5 inch diameters. Do not pre-drill these in the shop if you don't have to. You can drill them on site, but do not do it once the jacketing is installed or you will damage that underlying insulation. You can cut it with snips, but it leaves some burrs that can not look nice. The best method Jack and I have found is to use a step drill bit, which is not going to damage and leave those burrs. All right. So now we're going to move on to our trimer insulation. This is the foam part of that portfolio here. Here are offerings for a trimer. We have multiple kinds. They are based on density and named as such. There's different uses for these. All of them are tan with the exception of 1800, which is light gray. These all come in their own bun dimensions, but we can make pretty much any bun size requested, which we have done in the past. Some of the key properties, I'm not going to name these all, but the top three are that thermal efficiency, which is that low K value. It's easy to fabricate and install, and it is closed cell, so it has good water resistance. It doesn't have like absolute water resistance. It eventually will take on water, but it has good cell water resistance. So here's how we make this. It is produced in large buns on a singular line, actually, through a process that is quite chemically complicated, so I will not go into that. It is produced in these buns and then cut in sections. It is stored outside for a length of time for it to kind of cure and set. It gets this what's like called a skin on it. And then we sell these buns to our fabricator customers who will then use a cutting machine to create those pipe shapes that you see in this right picture, usually discarding the skin, and it just depends on the application what they're going to use this for. So some of the markets for trimer, this one is heavy industrial. You want to use our 2000 or our 2500, which is the workhorse of our product line. It's ideal for cryogenic to warm applications. Our 2500 is used almost exclusively in LNG, or cryogenic, excuse me. And then our 3000, 4000, and 6000 are aptly named because of their density. These are stronger. You're going to use these for pipe supports and specialty applications. Next market is light and industrial. This is mostly food and beverage manufacturing and storage. Examples of this would be like US Cold Storage, who owns large storage warehouses, Tyson Foods, ice cream companies, so on and so forth. Lastly, there's the commercial market. That's where you're going to use this 2550. This is for indoor chilled water applications where you require a 2550 ASTM E84 flame smoke rating. You can use up to our 1.5-inch thick trimer on this. This is ideal for those indoor data centers that are coming around. So this is absolutely applicable in data centers, and it will meet all of those indoor requirements for that flame and spread smoke. And again, we do have multiple resources online that go into length about this. So some of the limitations of trimer, again, it is closed cell, but will eventually take on water. It does not have zero water absorption or permeability. That ASTM E84 requirement is applicable for trimer 2550 up to 1.5 inches. And then it does have mid-range compressive strength when compared to our other materials here. So here's some of the key system designs for cold and cryogenic applications. I'm not going to go through all these, but it is again in an effort similar to CUI mitigation. You want to tackle all of these. You don't just want to aim for one. When you have all of these, it kind of helps create that perfect system that'll give you time and use out of it. So we're going to talk about vapor retarders. The selection of vapor retarder needs to be based on its permeance, which is perm for short. It is the rate at which water vapor passes through the vapor retarder. The purpose of this is to severely limit water vapor movement toward the pipe. The permeance is measured in units of perms, and a lower value or perm rating is better here. So the point of this slide is that the minimum water vapor permeance required is less than 0.02 or equal to. At colder temperatures, you're actually going to want to have equal to or less than 0.01. Just watch out for ideal lab performance compared to actual real-world field performance. There are vapor retarder materials which might have a lab result of 0.01, but with no joints present and in a carefully controlled flat test geometry, which would actually not hold up in applicable cold applications in the real world due to that rugged environment and the presence of so many joints. So just be careful. Regarding vapor retarders, we do offer both a tape and a film called Ceranex CX. We offer in different measurements, such as 540 and 560 for the film, and 520 and 560 for the tape. That's just representative of how thick it is. You're going to use the Ceranex over the foam, and then you can use that tape at butt joints or odd designations that you need to seal up there. So this is just an example of the service life of PIR. It's used around the world. When installed correctly, it offers 20 to 30 years of use in cold applications. I would encourage, we have a sales rep named Mel Rasco, who is the ultimate expert on Trimer. If you have any questions, I'm around, but if you can't reach me for whatever reason, Mel is a great resource as well. I know that was really fast, everyone, and I really appreciate it. It was a lot of information. I'm going to let Kelsey take back over here.
All right, thanks, Liz. As Liz mentioned, we did speed through this quite fast because we do have quite the robust product portfolio. So we often get questions all the time. If we're going to send out this presentation, we will send out the recording of this presentation in a follow-up email so that you can rewatch it or share it with your colleagues. Also, since we did go through this so fast, we often recommend you request a technical presentation or a lunch and learn. You can sign up here for an exclusive in-person or online technical presentation. We can cover this presentation that you saw today, or if you have another topic or something you want us to go into more detail about, we can certainly give a presentation on that as well. You'll also earn a certificate of completion, which can be submitted for some professional development hour credits. So keep that in mind because we did speed through this so quickly today. So we want to make sure you get all the information that might be as valuable to you. Also, another great resource for you is jm.com. It really does have a robust amount of information, including data sheets, the technical bulletins, the testing that we shared with you today. And it's really easy to navigate. You can kind of scroll through and see all of our products and then all of the feature documents associated with all those products that you may be looking for. So definitely look on jm.com. It has a variety of videos and additional resources like blogs and some past webinars as well. We also want to keep this conversation going. We know many of you are on social, so are we. So find us on LinkedIn. We have the Johns Manville Industrial Installation page on LinkedIn. There you can also sign up for our online newsletters to make sure that you're getting all of the up-to-date information that we have. We also have all of our videos posted on YouTube and as well as some quick snippets on Instagram. So definitely follow us on those platforms if you are on social media. And as I mentioned before, even with our technical presentations, you will receive or you are eligible to receive some certificate of completions. And then for watching this webinar today, you will also be emailed your certificate of completion as well after this webinar ends. So with that, I think we have time for just a couple questions. If you submitted additional questions and we don't get to them today, we will certainly reach out to you offline. And I will actually leave up on the screen this QR code for a technical presentation. Please don't hesitate to reach out to us to request one of those. So with that, a couple questions that we had that came in, a couple questions on CrossFlow for you, Liz. Does the CrossFlow have weep holes and how far apart and how to avoid drips and stains?
Yeah, so CrossFlow does not necessarily come standard with weep holes, but none of our metal jacketing does. Those are going to be made in the field. We encourage them 3 to 9 feet apart. You want to make them in the fields, but again, you don't want to make them when they're already installed on the pipe. You want to install them at the low point of the system to help water egress occur. You can make them with tin snips that will create some damming and burrs that you have to hammer down. And Jack and I have found that the best tool is the step down drill bit that's not going to cause that burring and damming. I have found after watching like Johnny Laredo install this, he makes them in 2.5 seconds. So it's not a big deal for them to make weep holes in the field. And it's becoming more and more accepted as a practice.
And you really can't make them in the shop or pre-make them because you don't know what pipe diameter you're going to be putting the metal jacket over. You don't know where the bottom is going to be for the drilling of the weep hole. So it has to be done in the field. I can't figure out any way to do them in the shop. They're field done.
Yeah, it's a mistake to do it in the shop because you're just gonna mismeasure and have to do twice the work with twice the material.
And then also about specifying crossflow, are there other brands that carry similar products?
I'm gonna let Jack answer this one.
Not at this point that I know of. CrossFlow is a very new product. It's one of our latest innovations. And I'm not aware of any other manufacturers that has a jacket similar to this one at this point.
I agree.
Jack, we often get questions around the XOX corrosion inhibitor, and I wanted to know if you could kind of expand upon it, how it truly is integral to our product.
Yes, it is. Boy, we've got, it's hard to do this one in 30 seconds because this is could be a very, corrosion is a complicated process. And we've got webinars that are already on our website. We have several lunch and learns centered around corrosion and corrosion inhibitors and methods to inhibit corrosion otherwise. So it's really hard to answer this in one 30-second snippet. But bottom line is it's integral to the product. 95% of the raw materials in our Thermal 1200 are actual corrosion inhibitors. It's activated by water, provides the coating on the pipe, the passivation layer, which keeps the water from contacting the pipe, which prevents the corrosion in general. And it keeps the pH out of the range where your corrosion would happen. So I would encourage going to the website to look at more or requesting a lunch and learn or even a webinar specifically for you and your firm, which we will be happy to do. And honestly, I don't care if it's 2 people or 200. We will do them.
Yeah.
And then one other question about metal jacketing, will we be offering aluminum end caps or tees?
At this point, we don't have that in in what we're working on our projects. So we currently have the elbows, the gores, and the cut and rolled metal, but not fittings beyond 90s.
Yeah.
All right. We are definitely over our kind of hour webinar today, but we appreciate all of your questions and participation today. And of course, Jack and Liz, we so appreciate you taking the time and sharing your expertise on our product portfolio. And for everyone else, if we didn't get to your question, or if you pre-submitted a question we weren't able to get to today, we'll certainly reach out to you and answer your question there. And again, as we mentioned, since we had to speed through today, please reach out and request a technical presentation or a lunch and learn, and we're happy to kind of go over a little bit more in depth into certain other topics. So we appreciate everyone's time today, and have a great rest of your afternoon.
Thank you so much, everyone.
Thank you.